Hello everyone, this is Horned Frog Engineering. Right now we're going to start on fluid statics and do some manometry problems. We're going to start with a simple one with a person swimming down 10 feet. And for this problem, we're going to calculate the change in hydrostatic pressure in PSI when swimming down to the bottom of the 10 feet deep swimming pool. So this is actually not foot, feet, plural. So this is going to be, we're going to be using this swimming technique throughout these problems. This is something that I was taught at school, and it's been super helpful when dealing with manometry problems. So we're just going to pretend that there's a guy, or this is you, and you are swimming from point 1 to point 2. Point 2 is 10 feet deep. So what you're going to do is you're going to start off, we're using the hydrostatic equation for this one. And whenever you see this triangle, the triangle means this is at PATM. And in terms of gauge pressure, this just means that the PSI G is equal to 0 PSI. So that's all that means. This means this is an open air, it's at PATM, and in terms of pressure gauge, you're just getting 0 PSI. So we're going to start off, but we're just going to set up our equation. So you have your P1, and since you're going down, you're going to put a plus because the pressure is increasing. And then it's going to be the specific weight of H2O, and then the depth is 10 feet. And that's going to equal your pressure at point 2. So a pretty simple problem. We're pretty much just trying to figure out P2 minus P1. What we want is P2 minus P1. What's the change in pressure when you're going from point 1 to point 2, from the surface of the pool to 10 feet down the pool? What's that pressure change that you're going to feel? So now we're going to solve for P2 minus P1. I'm going to switch P1 on this side. Pretty simple problem. And then you have your specific weight of H2O, and if you look at your textbook, usually it's in the inside cover of the textbook, it's 62.4 pound force per cubic feet. So now we're gonna put that over here, 62.4 pound force per cubic feet, and then we're gonna have to do some unit analysis, unit conversions. So this cancels out, and since we want it in PSI, PSI is pretty much just pound force per square inch. That's what PSI means. So we want this in PSI, so what we're going to have to do is per 1 foot squared, there's 12 squared inch squared. So now this cancels, that leaves us with pound force inch squared, and this is in terms of gauge pressure. So P2 minus P1 equals, if we plug that into our calculator, it is 2.4 times 10, 12 squared is 4.3. It's positive 4.33 PSI, and this is in terms of gauge pressure, by the way. So, and that is our answer. And this is using the swimming method. So you're going from point 1, you're starting at P1 plus the specific weight of water times 10 feet. And because you want this in terms of pressure, because this is in PSI, this is PSI, so you want this in PSI. So it's the the specific weight of water times the depth, and you're doing plus because you're the deeper that you go down the water, the more weight, the more pressure that you're feeling. If we did this problem from P2 to P1, then this would be negative. The pressure that we're feeling is going to be, the difference in pressure is going to be negative 4.33, but since we're going from a lower pressure to a higher pressure down 10 feet below, then it's positive 4.33 psi in terms of gauge pressure. And that is our answer. By the way, I am using the book called Fundamentals of Fluid Mechanics for these problems, but this one is specifically from one of our lectures. This is not, I don't believe this is a problem from the textbook. All right, let's go on to the next one.